Hi, this is Mrs. LaBarbera. This is Physics Chapter 9, Current Electricity, Video 7. Today's topic is series circuits. The objectives are: know the definition for series circuit, know the rules for current, voltage, and equivalent resistance for series circuit. Understand a series circuit is a circuit in which there is only one path for current to flow, so only one current that is the same at all points. Understand, adding resistance to a series circuit raises overall resistance because electrons must pass through all resistance. This reduces the current. Be able to sketch or select diagrams of series circuits including proper placements of meters. Use VIR chart. So VIR is voltage, current, and resistance chart, and Ohm's law to solve series circuit problems. Be able to determine the power or electrical energy used by a circuit component or the entire circuit. Be able to determine the effect of adding or removing resistors to the rest of a circuit. Definition of series circuit. A series circuit is a circuit in which two or more elements are connected end to end so that a single loop of current is formed. So there are three things. Same current flows through all the resistors. The potential difference across the bigger resistor is higher than the potential difference across the smaller resistor. For example, the 30 ohms will take a lot more potential difference than the 10 ohms. The third, by the time each charge makes it back to the battery, it has lost all the electrical energy given to it by the battery. So when it comes back, it has nothing left. Then the battery has to redo the work. So here is a schematic diagram for three resistors connected in series. So R1, R2, and R3. As you can see, the bigger the resistance, the more the voltage. Series circuit rules. Equivalent resistance. More resistors equals to more resistance. RT. The total resistance equals to R1 plus R2 and so forth. RT and R equivalent are the same thing. Current is the same throughout the circuits. I total equals I1 equals I2 equals I3 and so forth. I total is the current going through the battery. So again, I equivalent is the same as I total. Voltage drop all add up together. V1 plus V2 plus V3 equals V total. Again, V equivalent is V total. This is the voltage of the battery. And all circuit components and a circuit as a whole must obey Ohm's law. Remember Ohm's law, R equals V over I. R doesn't change. I is directly proportional to voltage, inversely proportional to the resistance, and V equals I times R. So here is a VIR chart: voltage, current, and resistance. So take a look at this example. You have three resistors connecting in parallel. Total voltage is 7.5 volts. When the switch is closed, what are the values you need to fill in the table when the switch is closed? So first is record all the R's. R1 is 5, R2 is 8, R3 is 2. Equivalent, you add everything together. And it tells you also the total voltage or the voltage of the battery. That's equivalent voltage is 7.5. The total resistance, you add everything together, is 15. I equals V over R. So 7.5 divided by 0.5, that gives you 0.5 amps. Since this is series circuits, all the I's are the same. So it's all 0.5. Then we can figure out for each voltage. 2.5, how did I get 2.5? I use I times R, 0.5 times 5. 0.5 times 8 give you 4, and 0.5 times 2 give you 1. As you can see, when you add all this together, you get 7.5. So also you should know the bigger the resistance, the more voltage it will take. Voltage in this case is kind of like energy. So the more resistance, the more energy it needs. So it's 4. The smaller the resistance, the least energy you need, which is 1. Okay, and over here is a medium voltage you will need. Take a look at another example. So we are doing the same thing and trying to fill in the table. So this time the value have changed. So when the switch is closed, what are the values? try to do it yourself, then you can compare with my answer. You can stop the video now. So here are the answers. All the resistance, equivalent resistance, voltage we actually don't know, but we know the current. This current is the total current, also the current in each individual resistor. So now if we know the I, we know the R, we can figure out the voltage. So for the equivalent voltage, we can use I times R equivalent, or we can add all this together. You should have the same answer, 480. Now let's take a look at this example. A 2 ohm resistor and a 4 ohm resistor are connected in series. So they are connected in series with 12-volt battery. If the current going through 2 ohm resistor is 2 amps, what is the current going through 4 ohm resistor? Since these are connected in series, so the current in one is the same as the current in the other. So the 4 ohm resistor will have a current of 2 amps, the same as the current going through 2 ohm resistor. This is because they are connected in series. Another example. So the circuit diagram represents 4 resistors connected to a 12-volt source. According to the diagram, you can see they're connected in series. Question 1, what is the total current in the circuit? So one way to figure out is to construct your VIR diagram and fill in the blanks. So 4, 6, 8, 6, total, you add them together. We also know the total equivalent voltage. So therefore, we know the total resistance is total voltage divided by total resistance. That's 0.5. So that's question number 1. Question number 2 is, what is voltage going through 8 ohm resistor? Since this is a series circuit, so all the current are the same. They are all 0.5. To find the voltage for each one, we simply use Ohm's law. V equals I times R. So 0.5 times 4 give you 2. And over here is 3. Over here is 4. To check your answer, you can add all this together. V1, V2, V3, and V4, see if it equals to 12. In this case, it does. So to answer your question, you can't just make a chart and say, well, the total current is 0.5 amps. You have to show using equation how you got 0.5 amps. So I total equals V total divided by R total. And you need to show how you got R total. So the total current is 0.5 amps. What is the V? V equals I times R, 0.5 times 8 ohms, which gives you 4 volts. So the voltage across 8 ohms resistor is 4 volts. Another example. So here's another circuit connecting series according to the diagram. So it tells you the each resistor's resistance, also tell you the total voltage. So you can make a chart to help you. In this chart, because they are asking you the electrical energy expended, the rate of energy expended, that is power. So you can also include in your power. So let's fill in the chart. 4, total is 8. Total is 8 because this is series circuits. So total R equals R1 plus R2. The other one given you is total V. Since you know total V, so you know the I is 2. They are all the same because it's series circuits. Therefore, you can figure out, since you know V, I, R, you can use any equation to find power. You can use V times I, you can use V squared over R, you can use I squared times R. You should have the same answer. That's question number 1. Again, make sure you show the equation. Question number 2, what is the voltage across 4 ohms? So the voltage is I times R. So both has 8. As you can see, 8 plus 8 is 16. Now we can also find the power using any of the 3 equations. You will have power. Again, to answer the question, you'll have to use the equation. I used V squared over R because you were trying to find total. We have to use V total divided by R total. V total squared divided by R total. So you have 32 watts. You can use the other equations. That's fine. To find the voltage across the 4 ohms, you use I and R. So R has to be 4 ohms. I is the same, so you have 8 volts. Okay, that's it for today. Thanks for watching. See you next time.